Unmanned aerial systems, drones, unmanned aircraft. This is a wave of the future. This is now. This is the Earth reimagined, the future delivered, and the past remembered. This connects us to the forest and to each other, as you'll see as we go through some slides and information as I go through the talk. So we'll go ahead and get started. The first part and the most important part of using the unmanned aerial systems is making sure you can put it together, take it apart. You can take off the propellers, put them on, take off the batteries, put them back in. Make sure you take off the part so you can see the videos when you're taking them, and you use this in a safe manner that is directed by the Federal Aviation Administration or FAA or the TSA, the Transportation Security Administration, as we use this tool and this device to look at the world around us. Now, the most important thing in using this and teaching research and service is there are 3 different ways to use this particular instrument. The first is to take individual pictures. You fly the drone up, you take individual images, and as you're used to doing that, and then you can download them. What's important about this is each image has geospatial representation, which I'll go into later and which is very important. The second part of this is flying a drone to take interactive video. In other words, you can take streaming video, you can take the video, edit it down, and use it as you wish to make points about the environment later on. And a third, and I think the coolest way of using the drone or unmanned aerial system or unmanned aerial vehicle is in your 2D or 3D, which is 2-dimensional or 3-dimensional flights. What you do is you take your drone and your controller device and you get an area of interest and you get your overlap, in-lap, side-lap, speed of your drone, height of your drone, put it on the ground for your area of interest. You press a button from your controller and there goes the drone up in the air. It's flying this way and it stops and it comes back and goes the other way. It stops. And it does that in what we call a 2D flight. If you're doing 3D flight, it goes at 90 degrees, flies this way, stops at each vertice, takes an image, and keeps going on. And it comes back and lands at your feet. And the beauty of this is that as it's flying, it takes individual images at each vertice and takes those individual images, and you can then photo rectify these when you take this back to a laboratory in your GIS system and your ArcGIS system, and it makes a orthophoto correct map to the Earth's surface. Now that took days before, now it takes a matter of hours to do this sort of thing, and you come up with this finished product. And this is what is really neat in the whole concept of teaching research and services. You've got your automatic project right there. And that's what we do. We put the drone in your hands. That's the most important part. This image shows how we take the drone from the field for our 2D and 3D flight, and we're using Drone to Map as our download into our ArcGIS system. And we take that download into there, and you can see each of those blue points is where a photo was taken. Each of those photos has GPS or global positioning points to them, which is real important because you can use that information also. And so what you have for your landowner or your user right now is that map image right in their hand, which then can be sent to them or used as we develop that. So in teaching, we go through a 4-step process. A rubric, which is developed as our mentored undergraduate scholarship program. And the first thing we do is we make sure that you are safe with the drone, that you know how to take it apart, you know how to put it together. You know how to take off the propellers, you know how to put them back on. You know how to take out the battery, you know how to put it back in. You know how to put the lens cap on, you know how to take it off, you know how to connect it to the controller. And you do that until we're satisfied that you know the steps in looking at this particular instrument. The second thing we do is we put it in your hands. We give it to you, and you fly it. You fly it as pilot in command, and you have a visual observer following FAA guidelines. And you put the drone up in the air with instruction, and you do exactly what we just said. Part 2 of the rubric. You take pictures, your pictures, they belong to you. Then you do streaming video. right then, first time out. Then you land the drone, you program your flight of area of interest, and you push the button and you watch the drone fly and come back and do the same process again, taking the drone in and taking it into the computer, and you're loading it up to drone to map. You're the one processing your image of your world reimagined. Next thing, we take you back outside and we have you do a measured height of something. It could be a light pole, it could be a tree, it could be a measured pole. That's what we do. You fly the drone up, then you take your standard forestry clinometer that you all have, and you take your measurement tool and you look at the height. And then you go back in the laboratory and use your pictometry, hyperspatial imagery, and you measure height on screen and sit to the same exact material there, and you do the statistics right there. And so you have the entire process, and this is done in 1 day. From the time you take this out until you have this final product. And then you're on your own with us and our guidance. We have a 4-member team called the Drone Squad that works with you to come up with ideas for the future delivered. And what this means is that you come up with ideas. And one of the first was, how do you measure height of the drone? Well, it turns out, we did it against a measuring pole or a tree. It turns out that the most important aspect is you need to land the drone between each measurement to reset that GPS. Once we found that out, it became the future delivered. And so then we give this out to forest management plans. Students can go out, take a 400-acre tract, fly it in a single day, come back in, process this imagery, and they can look at ips, bark beetles, they can look at mortality in the stand, they can look at differences between hardwoods and pines, they can look at drought. And since they've landed their drone on the ground, since they know that, they can get height of the area and bring that back in and begin to make their management decisions for themselves and looking at this world around them. One of the cool applications developed with the students is iNaturalist. iNaturalist is the world's largest citizen scientist program. There are 8.6 million images worldwide put into iNaturalist. Well, we said, okay, since each image is georeferenced, can we add material to iNaturalist from a drone or an unmanned aerial system? And the answer is yes, we can. So we did it. Once again, future delivered. We took it first of all to mistletoe plants. Mistletoe is a hemiparasite. It's green, and then it grows down into the branches through Astoria. And the students took and counted the number of mistletoe plants on the tree. And it's important we know the number of mistletoe plants because the more there are, the more potential damage there is. And we did the standard method from the ground. We found out there's twice as many mistletoe plants found with the drone as there was there. And we added all that information to iNaturalist as our first product. So we went further into the forest and looked at trees in our parks and found out that if we put the drone right above nadir, right above that tree, and then took that and compared that to Google Earth Pro at your fingertips or to pictometry hyperspatial imagery, that they all came out and give you the same location. And we added that to iNaturalist as a new product called Drones for Biodiversity. And we've since expanded on that. And then we have a whole product worldwide that you can add to it as you wish. And so that's important. At the same time you're flying and doing this, you can hazard rate the trees. We hazard rated the trees with the standard CTLA method and found out that there was no difference between that method and on the ground, and found out that this is very important to the system. So going further, then each student develops their own project. One is the use of an image from 80 years ago as georeference, and they flew the drone in 2D in our current space, and then we're able to compare cover types, riparian zones, vegetation over the 80-year period, and keep a permanent image here so it's the past remembered. Beauty. The world around us is beautiful. We take the drone, we take pictures of our labyrinth. Our labyrinth is a place of peace, of quiet, of nurturing. And we took the labyrinth, and then we took the drone and flew it down a 3-mile historic trail in our community and put that out as an interactive map from a drone using video. So a number of different ways to use it. We went to a park, community near us, a 28-acre park, We're able to look at cover type. We're able to look at forest types with the drone in 2D and 3D flights. We're able to look at the trails that we just talked about. But the neatest thing is we're able to actually count milkweed pods on the milkweed plants to look at the status of milkweed for the migrating monarch butterfly. And then we're able to count blossoms on the Neches River rose mallow, a potentially threatened species in Texas, and so we can see the use of this throughout the area. And then Dr. Yikai Hung, a member of our drone team, took the drone and flew it over the same exact area 7 times with ground control points over a 7-month period and found out that if you do this, you must have static ground control points that you can refer back to because that image shifts because of the shifts in the satellites. Then you can do streaming video. Our chief pilot, Dr. Dan Unger, another member of our drone team, takes streaming video, edits them down, and forest types. And you can see here that you can look at recreation management, stream ecology, riparian zones of a beaver dam that used to be there. You can look at a forest type and come up with what the stand composition is. You can look at recreation management and see the status of recreation areas. Are they eroded? Are your recreation facilities intact? And then you can look at the areas of range management and see what range management is, what the transition to forest. And you can see in the range management images, there are what's called desire trails or animal trails. So we went back to our own community, flew 100 desire trails, and mapped them out and sent them off and looked at those for management. These are all undergraduates doing the flying. Okay. Cattle Mounds Historical Site. A little community called Weeping Mary outside of Alto, Texas. April 12th, 2019. Getting ready for their celebration. So what we did was we took out the drone and we flew the Caddo House, which is one of the symbols, the Caddo Nation on the site. We took 625 images in Pix4D capture and made a, which you're going to see in just a second, made a 3D rendition of the Caddo House. And we took also the visitor center of the area and the Snake Women's Garden as they got ready for their celebration. Okay? And this is to show the interaction. So let me just show this to you. The streaming video, 625 images morphed together in what's called the Caddo House. That's 1/8 inch resolution. Snake Women's Garden, the visitor center. Please note, getting ready for the celebration of the landscape. The world reimagined. Getting ready for the celebration. Giving this to them as a way of remembering their site. But it was not to be. 24 hours later, April 13th, 2019, an EF3 tornado destroyed the site. Caddo House was gone. Caddo House, or Kawat, was gone. The visitor center destroyed. 40 vehicles gone. 1 fatality, 35 injured. What I wanted to point out to you is right where the Caddo House stood, there's a yellow dot. That yellow dot is Jeff Williams, our systems analyst from our program. Grabbed a hold of the ground, was able to stay there on the ground as the tornado swept over him and the others. He's also president of Friends of the Caddo, which was part of the celebration. He also helped build Kahut Kawat, or the Caddo House. And he also helped others around him as the storm passed. And so you're able to use this imagery to show where the people were connected. And it was important to them later on as part of healing to know who was with them, who was around them, as we used this drone image as a way to look at the area. But using the same images We were able to make a 3D printed model from the 625 images which I told you about before, so it becomes a past remembered. And this became a symbol event, because these were given to the survivors, who are called Shaho, or those that survive, or tornado. So this is made on our 3D printer by Yanli Zhang, the other member of our drone team. And this is a way of connecting people to that landscape with the imagery. And in fact, smaller models were made, so each person got one from Jeff Williams. These were given to Jeff Williams, and he distributed these to the people as a way of connecting. And since this is really correct in its size, it's going to help in the reconstruction and the reconfiguration of this landscape. So, drones give us the world reimagined. They give us the future delivered. And they give us the past remembered.